and the derivative of trigonometric functions. We'll get started with the chain rule, but first I have to change.
Find the derivative of a composite function, you're told. Well, it is very important that you know the chain rule code, but I don't even know what a composite function is. I'll explain it for you. You ain't gotta be a math whiz. A composite function is a function inside another function. Now you incorporate the chain rule with the following examples. Don't worry, I'll walk you through it. It's not too much to handle. Take the derivative of the outside function, leave the inside function aside. Then take the derivative of the inside function, and that's what gets multiplied. What's that? You don't get it. Did you even pay attention? Don't you be blaming calculus for your lack of comprehension. Okay, I'll explain it more slowly this time, but don't make me repeat it because I'm running out of rhymes.
For example, if you have y equals the square root of x cubed minus 4x, you can just rewrite this as y equals the quantity of x cubed minus 4x to the 1/2. It's the same thing, but this will just make things easier. So now you can take the derivative. You start off by using the power rule, so you bring down the exponent, and you keep what's inside the parentheses the same, and then you subtract 1 from the exponent, so it's negative 1/2. So now you incorporate the chain rule, and you take the derivative of the inside, and that's going to be, I'll just write it off to the side, 3x squared minus 4. And now you multiply this times the outside function. So your final derivative is y prime equals 1/2 x cubed minus 4x to the negative 1/2 times 3x squared minus 4. And that's your final derivative. So really the best way to know trig functions is to memorize them, and I made a little song that can help you with that. Sine, cosine, cosine, negative sine, tangent, secant, squared. Cosecant, negative cosecant, cotangent, secant, secant, tangent, cotangent, negative cosecant squared. But if that sounds not catchy enough for you, I can show you how to find the derivative of trig functions by using the definition of the derivative. So now I'm going to show you how to find the derivative of trigonometric functions by using the definition of the derivative. So you have to remember that the definition of the derivative is the limit as h goes to 0, f of x plus h minus f of x all over h. So in this case, we're going to try to find the derivative of cosine of x. So f of x equals cosine of x, therefore f of x plus h equals cosine of x plus h. And so we set the limit, the definition of the derivative to, in terms of cosine of x. So you have the limit as h goes to 0 of cosine of x plus h minus cosine of x all over h. And here you have to remember your trig identity rule. And in this case, cosine of a plus b equals cosine of a cosine b minus sine a sine b. And And that's what it's going to look like. And here, I skipped a few steps, but basically what happened was I moved this minus cosine of x to this side, and then I factored out the cosine of x. So you're left with cosine of x times cosine h minus 1. And then the other side, minus, I separated these two, minus sine of x times sine of h over h. And the reason why I did that is because you have to remember your trigonometric limit identities, and it's going to be a lot simpler now because this right here, just this part, right there, that, you see how it kind of looks like that? That's going to equal to 0. And then this over here looks like that. That's going to equal, wait, no, not that. This right here. Oh, wait, no. That right there is going to equal 1. So then, since this equals 0, and it's going to multiply times that, so it's just going to be 0, that's where this is. And since this right here equals 1 times sine of x, you've got 0 minus sine of x. And so your answer is negative sine of x. And if you remember from the song, it's sine, cosine, cosine, negative sine. So that's just a whole lot simpler if you know the song, because then you know that the derivative of cosine of x is negative sine of x instead of doing all of this. But this is just so you know how it's done if you prefer it this way. So you have to remember your definition of the derivative, your trig identities, and your limit trig identities too.
Sine, cosine, cosine, negative sine, tangent, secant, square. Cosecant, negative cosecant, cotangent, secant, secant, tangent, cotangent, negative cosecant square.